All right, here we are with continuing with section 2.2, pre-calculus. You should be on page 7 of your packet. At the top of the page, you see there's example 4, and here are the things that they want us to do. They want us to apply the leading coefficient test, find the zeros of the function, plot sufficient solutions, and draw continuous curves through the points. So here's what we're going to do. First of all, I'm going to go ahead and list what we know about this function, or about the behaviors. I look at my degree is 3, my leading coefficient is 1, so I know this is going to fall left, and it's going to rise to the right. All right, so there's the behavior, or the leading coefficient test. If I want to find some zeros here, then I'm going to set the function equal to 0. I'm going to solve this. The method of solving here is going to be factoring. I'm going to take an x squared out, and you get x minus 2 left. This is indicating that my zeros are at 0 and 2. Okay, going to go ahead and start plotting some of this. I've got a 0 at 0, and I've got 1 at 2. I know that at 0 here, because it's multiplicity, because of the x squared, I know that it's going to create a relative min or max, and then at 2 it's going to cross over my axis. So those are some other behaviors that we're able to identify. All right, so I'm going to go ahead and build a table of values then to get some other points that I can plot. If I know I'm crossing at 0 and also crossing at 2, let's fill in some values here. Let's go ahead and see what happens on the left side, so -1. If I put -1 in as an input, you can calculate that. We're going to get -1 minus 2, which is -3. So let's plot that point. I know what happens at 0. Let's find out what happens at 1. If I put 1 in, I get 1 minus 2, which is -1. Plot the point. And I suppose what we can do is find one more. Let's find out what happens if we put 3 in. 3 to the third is 27 minus 2 times 3 squared, 2 times 9, which is 18. So we are getting 9 for that. So about right in there. All right, there's our zeros. We've got where they cross the axis. We also know the behavior of the curve, so I'm going to go ahead and sketch this behavior now. Comes from -infinity, hits the x-intercept at 0, comes back down to -1, and then back up. There's our graph. All right, let's see what we can do here with this next one. I'm going to go ahead and copy it onto a clean page here, but the first thing that we're going to do is do the end behavior. But this function is f of x equals -2 x to the third plus 6x squared minus 9/2 x. So we're going to, the end behavior, since my degree is 3 and my coefficient, the a value, is negative, I know it's going to rise left and it's going to fall to the right. We want to set this equal to 0 so we can solve it. All right, there's a couple things that I'm going to do here. I'm going to go ahead and multiply everything by 2. That gets rid of my fraction. The next thing that I'm going to do is get rid of my negatives. I can multiply everything by a negative, both sides. It's still keeping everything balanced. What I'm trying to do is get it into a form where maybe I can factor or use the quadratic formula. All right, I can take an x out. When I take an x out, I have left 4x squared minus 12x plus 9. So either you're going to use the quadratic formula here, or what you can do is attempt to factor it. And I'm going to go ahead and factor this because it does. It's going to be 2x and 2x. Both signs are minus. And the factors 9 would be 3 and 3. You can see here that my middle terms are 6x and 6x, both being negative, which would add to 12 in the middle. All right, what this tells me then my zeros are, the zeros occur at 0, coming from the x in front. It also occurs at 3/2 twice. That's multiplicity. So let's go ahead and graph what I know. A 0 occurs at 0. And at 3/2, which is 1.5. Okay, now we just need to know what happens with the graph in between all of that. So what I recommend that you do is you build a table of values. And let's start putting some numbers in. Let's go ahead and put in, see what happens on the left side. So let's put in -1 and see what we get. You have to put it back into the original. So you have -1 cubed, -1, so that's going to be 2. -1 in for the x squared would give us +6. And then -9/2 times -1 is +9/2, which is 4.5. This gives us a total of 12.5. So you can see here that I know my graph is coming from a large value, and it's going to then intersect here at 0. What I don't know is what happens next. Okay, how low it will go. Let's put in 1, see what happens. If I put 1 in, I get -2 plus 6 minus 9/2. All right, that's 4 minus 4.5, which is -0.5. A 1/2, -1/2. I also know, so it crosses over, it's going to intersect this x-axis since it's a double root. It's a multiplicity. Let's see what happens when x is 2. Well, this will be our last one that we do. -2 times 2 to the third is -16. 6 times 2 squared is 24. And 9/2 times 2 is -9. So basically what we have is we have 8 minus 9, which is -1. So plotting that point, so my graph touches and then goes back down. And then it follows the behavior that we use with the leading coefficient test. So here's some things that you have to keep in mind. You do have to plot points, build a table of values. You need to find exactly how high and low your values are so that you can get an accurate sketch. That's how you graph your polynomial functions. All right, another thing that we're going to look at here today is finding the polynomial function that has the given zeros. What you need to do is write your expressions. If I know that I have zeros at -7 and 2, then I know my function is f of x equals, you do need to make sure that you use the correct notation. For a 0 of -7, the expression is x plus 2, sorry, x plus 7. And for 2, it's x minus 2. To finish this polynomial out, all we're going to need to do is FOIL. So f of x equals, as I FOIL this, you get x squared minus 2x and 7x is plus 5x in the middle. And 7 times -2 is minus 14. So there's our polynomial. This is a 5. All right, let's look at the last one here. We got three different zeros. So a 0 of 4 would actually give us x minus 4. It's always x minus the 0. X minus your 0. So when I have a 0 of 2 plus the root 7, it's x minus parenthesis 2 plus the root 7. And then I have x minus parenthesis 2 minus the root 7. All right, when I do this, because these are two zeros that go together, anytime that you have an irrational 0, there's always a pair of them because of the plus and minus. I'm going to FOIL those parts together. Before I FOIL, I'm going to take care of the sign x minus 2 minus the root 7. And then I've got x minus 2 plus the root 7. Let's go ahead and FOIL these. You got x times x, you have x squared. X times negative 2 is minus 2x, and x times the root of 7 is plus the square root of 7x. Negative 2 times x, negative 2x. Negative 2 times negative 2 is plus 4. Plus 4, and then I've got negative 2 times square root of 7 is minus 2 square roots of 7. I'm going to have one more term to multiply through. Negative square root of 7 times x is negative square root of 7x. Negative square root of 7 times 2 is minus plus 2 square roots of 7. And negative 7 with the square root times itself is minus 7. Now you're going to add like terms, and let's show you what we have left. When I add my like terms, I have x squared. I'm going to go ahead and show you some things here that cancel. We've got the minus 7 square root of 7x with the plus. We've got the 2 square root of 7 with the minus 2 square root of 7. So we end our result with minus 4x, and 4 minus 7 is negative 3. All right, we still have to multiply that out with the x minus 4. And x squared, the one that we just found, minus 3. So our polynomial is, so f of x equals, we just have to now multiply these polynomials together. We get x to the third minus 4x squared minus 3x minus 4x squared again here, and plus 16x. Negative times negative there with the 4 and 3 is plus 12. And final step, add all of our like terms together. This is going to be our final answer. F of x equals, we've got x to the third minus 8x squared, negative 3x, and the 16 is plus 13x, and plus 12. All right, there's your polynomial. Make sure that you write with the polynomial function, the term f of x equals, but that's your final answer. All right, we got one more test to talk to you about. It's called the intermediate value theorem. And in order for us to use the intermediate value theorem, you're going to use your calculator. So go ahead and enter this f of x equals 3x to the third minus 7x squared minus 21x plus 20 into the y1. And we'll talk about the rules here. About what this is, let a be less than b. So a, would just be some x values like this, a and b, and then your function is f of x, that's the y value. So all we're saying is the result of these, so f of a and f of b, it'd be the output. If f of a and f of b yield one positive and one negative value, then on the interval between a and b, occurs at least one 0. So here's what you're going to do. You're going to go and put this into y1. You're going to build your table, and you're going to then go view your table. You want to build it so that it is using integers. You can start at 0 if you would like, but what you're going to see is this. You're going to have a table, x's and y's, and I'm just going to go ahead and show you some values from 0, if that's where you start. You can see the table shows you at 0 you have 20, and at 1 you have -5. At 2 you've got -26. At 3 you've got -25. At 4 you have 16. So I'm going to go ahead and talk about this intermediate value theorem, or this test here. So you can see between the numbers of 1 and 0, you got a +20 and a -5. So since one of them's positive and one of them's negative, we know that in this interval between 0 and 1, there occurs a 0. The zeros occur in this interval. We don't know exactly what the number is, but since there's a sign change, we know that it has to cross the x-axis. There's also another one between 3 and 4 because of -25 and 16. So I want you to see if you can find another one. There should be one more 0. You might have to use your table and go smaller than 0. But if you should find the other one, and you'll see that it occurs between -3 and -2. All right, so we know that this has 3 zeros, 3 real zeros, and they happen to occur somewhere within these intervals. But that's what the intermediate value theorem tells us. All right, this is your assignment for tomorrow. And what I want to show you on this assignment is we've already done this first section, so you're just doing this second section here of that assignment.